Hi, I'm Dr. Karen Agar, and in this video I'll talk about hash sets, one of the many collection types in Java. We'll first start by trying to identify exactly what a hash set is. In English, we like to refer to a set as a collection of things, but it's unlike a list where that implies order. So when you think about a hash set, I want you to remember that it is unlike a list because the items that are stored in the set are going to be stored without order. Another thing to note is that all of these items will also be unique. So this is kind of my formal definition here, a collection of unique items without order. But let's look at when that might be a good idea. For one example, if I wanted to store a collection of email addresses. Maybe I'm putting together a set of all student emails in my class. I want to make sure that every student's email is only entered one time, so I do want a unique collection, right? But the order that I store those email addresses in may not matter. This could be a good example of when you might want to use a hash set data structure. Just like we've seen with array lists, the HashSet class is going to contain many methods that allow us to interact and perform functions on the set. Add, remove, contains are three very common ones, but you can see the Java API for a full list. Now to get into some of the nitty-gritty details about hash sets that happens behind the scenes, but you should probably be aware of. Unlike a list data structure like an array list, a hash set will be less expensive for inserting new items. This is because the way that's stored behind the scenes does not use contiguous, or you can think continuous, memory to store these items. If you think about having a list structure, let's imagine that I have a top 10 playlist of songs, right? If I then have a new item come into that list, right? Let's say a brand new item, a brand new song came out, it's now number 2 on the list. Imagine that I'm going to have to stick it in the middle of that ordered list, and a domino effect happens where everything below that will have to move down. Internally, when your computer processes this, this is pretty expensive to do with a list or an ordered collection. A set does not care about order, so you can add new things to the set and grow it in a much less expensive fashion. On the flip side of that, a set is going to be more expensive to retrieve items. So let's again imagine that you have all of the email addresses stored in a set. I like to imagine these as just each of them being on a sheet of paper in a bucket, right? They're all stored together, but there is no order. When you go to grab an item out of that set, you have no idea which item you're going to get out first. It is completely possible to grab every single item out one at a time, but again, the order is not there. This means that if I was looking for a specific item in that set, like let's say I'm looking for Bob's email address, then it's possible I have to go through every single item in that set before finding Bob's email address or saying, Bob's email address isn't in here, right? Compare this with storing email addresses in a list. If I had that list sorted in alphabetical order, then as I parsed through the list, once I got to a C, if Bob's email starts with the word Bob, then I know that I don't have that email address. So that's kind of the idea behind this being more expensive for retrieving items out. Again, I want to point out that hash sets do not allow duplicates. So you can think about every sheet of paper being in that bucket of email addresses having to contain a unique email address. So here we can see the syntax for declaring and initializing a new hash set. Notice that it looks almost identical to declaring a new array list. Inside the carets here, I need to put the type that I want this set to store. Notice that just like with array list, the type has to be a reference type. This means that you cannot put one of those 8 primitive types inside these carets. For example, if I had a class named employee already declared, I could store a set of employee objects, that is totally fine, using the syntax here. If I wanted to store things like whole numbers, like ints, then again, I can't put the primitive type int inside these carets. But what I can do is use one of the 8 primitive types wrapper classes, like this. Here I've created a hash set called set, and this is going to store integer objects. Again, these are just wrapper classes for primitive types. There will be another video about that later to discuss this in more depth. Some of the more common methods for the HashSet class include contains and add. These are methods that can probably be found with examples in your textbook, but you can always refer to the Java API for a full list and some examples. As a last note, just like the ArrayList class, you must import the HashSet class to use it, and you'll find it in that same package, java.util. So let's look at a brief example. If I wanted to store that collection of student emails that we discussed, then I'm going to store those as strings. Here's my syntax where I've created a new hash set. See that I said this hash set will contain strings, and I've named it student emails. Then if I wanted to add email addresses to it, I could use the HashSets add method like so. Here, my set named student emails, I've added bob@uga.edu, and then Jill, and then my own email, kagar@uga.edu. Notice that all 3 of these are unique. If I tried to add a duplicate, like let's say I again tried to add bob@uga.edu, I will not receive an error. This will compile and run. However, Bob will not be re-added to the set. So if I were to then run the code system.out.println student emails.size to get the size, the int returned here that would be printed would actually be 3. It's going to ignore this duplicate request to add Bob's email. Notice here that just like with the array list, the method here is size, and I want to compare and contrast that with the .length method that you might be familiar with strings, and the .length attribute you might be familiar with arrays. It's called .size when you're working with hash sets. And one thing that I've seen get many new programmers with hash sets is this. If I would then like to loop through my hash set and print out each individual item, one thing I cannot do is use a typical for loop with indices. Why? Hash sets do not maintain an order, so there are no indices involved in hash sets. I cannot get the first element or the second element or the 12th element out of a set because there is no order. So what this means is that when we loop through a hash set, we only have one choice, and that is that nifty enhanced for loop that we learned about. So here's an example using the enhanced for loop here to loop through the student emails hash set. Again, just like we've done with arrays and array lists in the past, I put the name of my collection on the right-hand side of the colon, and I pull out each individual string one at a time and store it in some temporary variable. I can then print it out or do anything here with it that I would typically do with a retrieved value.